Kawasaki disease was first reported in 1967, after sudden outbreaks in 1979, 82, and 86. This illness was on the rise for 30 years. The cause for the emergence and the outbreaks has not been explained yet. Japan is made of 47 prefectures. We correlated prefectural annual incidence of Kawasaki disease to socioeconomic and climatic variables. We examined both spatial and temporal correlations. Our spatial correlation analysis pooled the data between 1979 and 2010. The panel A shows total fertility rate where smaller values are colored black. Panel B presents incidence of Kawasaki disease where larger values are colored black. These two maps are very similar, implying that these two variables are correlated negatively. This finding indicates that as the number of children in a family is larger, the number of Kawasaki disease patients is fewer. Panel A shows that the annual incidence is correlated with the total fertility rate which preceded the incidence by 15 years. In panel B, the incidence shows a strong negative correlation to the total fertility rate which was recorded 15 years prior. This time series regression equation was built based on the prefectural data recorded between 2000 and 2010. Total fertility rate recorded 15 years prior was used to explain the incidence. With this time series equation, both the future and the past can be predicted year by year from the starting time point. Panel A shows the total fertility rate after 1940s. This data was substituted into the time series regression equation, and the incidence was predicted sequentially backward from 2010, resulting in the dashed line in panel B. Here, the emergence of Kawasaki disease in the late 1960s and its subsequent increase were reproduced. The emergence in the late 1960s was predicted because the fertility rate decreased rapidly between 1940s and 50s. This brought us to hypothesize that the dramatic fall in the fertility rate led to the emergence of Kawasaki disease. Of note, there's a knob around 1981 on the dashed line of the predicted incidence. This knob appeared because of the sudden decrease in the fertility rate in 1966, which was brought about by a superstition. Based on this tiny knob, I speculate that a sudden drop in fertility rate may have triggered the outbreak 15 years later. Force of infection is defined as the rate at which an individual is infected with a microbe in a year. Force of infection is approximated as the inverse of mean age of patients. Kawasaki disease, hand, foot, and mouth disease, and chickenpox show almost identical distribution, implying that Kawasaki disease is a viral infection. These distributions are very similar to that of total fertility rate. In another word, the more children in a family, the more intense that transmission is for viral infections and Kawasaki disease. Age-adjusted force of infection can be estimated by these formulas. Collectively, as the number of children decreased, force of infection of many infectious diseases decreased. Consequently, the incidence of Kawasaki disease increased, as we hypothesize. In addition, a dramatic perturbation, as was the sudden decrease in the fertility in 1966, may provoke an outbreak over time. The fertility rate in East Asian countries, including Japan, decreased dramatically by 1970s. Currently, the fertility rates of the emerging economies in South Asia, Latin America, and the Middle East are declining. This figure illustrates the temporal shifts in the non-specific IgG in our hospital. The levels of IgG declined suddenly in all age groups in 2020, the first year of COVID pandemic. This was presumably because the hygienic behaviors such as wearing of face masks reduced the force of infection. Fertility rates are decreasing in emerging economies. Furthermore, many countries suddenly became hygienic due to the COVID outbreak. Consequently, force of infection of microbes are waning. This is a repeat of the situation in Japan from the 1950s to the 1970s. Therefore, Kawasaki disease may outbreak sporadically in many different places on the globe. If we use the 15-year time lag mentioned earlier, then these outbreaks could occur in 2019 plus 15, or in other words, in 2030s, which is a very rough prediction.